This is Geometry, Chapter 3, Section 5, in which we will be proving lines are parallel. If you think back to what we did in Lesson 3.2, we started with parallel lines, we cut through them with a transversal, and we got special relationships from the angles. This time we're going to go the other way. We're going to know that the angles have special relationships, and we're going to use those relationships to prove that means the lines are parallel. So a lot of what we talk about in this lesson will just be the converse of what we talked about back in 3.2. For example here, if we know that the corresponding angles are congruent, postulate 3.4 tells me that means the lines are parallel. That's the converse of the corresponding angles postulate, so they call it corresponding angles postulate converse. Remember back on the other one we said if two parallel lines are cut by a transversal, then corresponding angles are congruent. Now we're saying if the corresponding angles are congruent, that means the lines are parallel. So we're going the opposite direction. We're starting from knowing that the angles were congruent, and that means the lines are parallel. Now that one's a postulate, so we don't get to prove that. I know, breaks your heart. Another postulate, postulate 3.5, is a very special postulate to us. It's called the parallel postulate. If we have a line and we have a point somewhere not on that line, I can only draw one line through that point that's parallel to the first line we had. Okay. Think about that for a minute. You have a line, you have a point somewhere off of the line. I can draw lots of lines through that point. That there's no question of. But only one of those lines is going to be parallel to the first line we had. Okay, there's only one way to draw one with the same slope through there. Now, as we said before, most of this is going to be converse of what we did before on 3.2. Theorem 3.5 is one of those cases. If we have alternate exterior angles congruent to each other, that tells us we have parallel lines. Before we had if the lines are parallel, then we knew the alternate exteriors were congruent. This one is the opposite direction. If we know the angles are congruent, then we know the lines are parallel. And there are a couple of others that are similar here. I'm going to jump down to 3.7 because it's more related to 3.5. I don't know why they put these in a different order than logically would make sense to me. But alternate interior angles being congruent tells me that the lines are parallel, just like alternate exterior does. Okay. Whenever I see alternate angles, whether they're interior or exterior, if I know they're congruent, that tells me I've got parallel lines. Not to be confused with 3.6 here, the consecutive interior angles converse. In this case, remember when we had consecutive interior angles, they're not congruent, they're supplementary. So if those two angles add up to 180, that tells me the lines are parallel. And then we also had the perpendicular transversals theorem before. This is the converse of that one. If two lines are perpendicular to the same line, that means they're parallel. Okay, as we did in lesson 3.2, let's think about the lines on your notebook paper. All of those lines going across the page are perpendicular to that margin line. Well, since they're all perpendicular to the same line, that means they're all parallel to each other. So let's apply a few of these theorems, or postulates, as the case may be. We need to decide which lines are parallel, if any are, based on the information. And then tell how we know that. So if I know that angle 2 is congruent to angle 5, where are 2 and 5? 2 is off of line M, 5 is off of line P. So if any lines are parallel, it's going to be line M and line P. So I'm going to ignore line N for the time being. Just not even look at it. I'm just looking at line M and line P. What kind of angles are 2 and 5? They're between the lines, so they're interior. They're opposite sides of the transversal, so they're alternate interior angles. So that tells me that line M is parallel to line P because of the alternate interior converse. If you wanted to use the number for it, whatever that number was, 3.7 I think it was, that's fine. But you can just give it the name as well, and that's probably easier than having to look up the number again. Okay. What about angle 3 and angle 1? The lines they're on are M and N, so I could care less about line P right now. What kind of angles are 1 and 3? Hopefully you're saying to yourself that they're corresponding angles because they're in the same basic place. Since they're corresponding angles, we can say they're parallel, M is parallel to N, by the corresponding converse. Okay. Again, you could look that postulate number up if you just really want to, but you don't have to. You can just give it by the name, and that's fine. One more of this kind. Angle 4 and angle 5 are supplementary. Well, that tips me off that I'm probably looking at consecutive interiors or consecutive exteriors. They're between two lines, so they're interior. Which lines are they between? N and P. So N would be parallel to P by the consecutive interiors converse. Okay. One last idea here is using these angles to find values. They want us to find the measure of JRS that would make line G parallel to line H. Now, which angles are we interested in this problem? We're interested in JRS, which is here, and we're interested in RSK, which is here. What is the relationship between those two angles? They're interior angles, they're between the lines, opposite sides of the transversal, so they are alternate interior angles. What we know about alternate interior angles is they need to be congruent. So each of these angles is equal to each other. Now, a little algebra, moving 21 over, moving 5x over, gets us 2x equals 28. So x is 14. Now all we have to do is plug the 14 back into JRS. 5 times 14 is 70, plus 7 is 77. Okay. Let's consider another one. QRS and RSK. What's the relationship between those two angles, QRS and RSK? Well, those are on the same side of the transversal and they're interior. So same side or consecutive interior angles tells me that they have to be equal to 180. Well, if they're equal to 180, I can clean that up a little bit Move the 20 over to get 200, and then divide x equals 10. Okay. We know x equals 10. What are we trying to do? We're trying to find angle JRS again, because that was the directions at the beginning of this. We're trying to find JRS. Well, we don't have any formula for JRS, but we do have a formula for QRS. QRS equals 12 times 10, 120, minus 15 is 105. Now, what do we know about QRS and JRS? They're a linear pair. They make a line, so they're supplementary to each other. So JRS is 180 minus the 105 we found, which is 75. Okay. As before in 3-2, you have to ask yourself, what kind of relationship do the angles have? Are they congruent to one another? Are they supplementary? How do you know? Alternate interiors, alternate exteriors, and correspondings are all congruent to each other. Consecutive interiors and consecutive exteriors and linear pairs are all supplementary to each other. So the key before you even start writing equations, folks, is to make sure you know that relationship. What kind of angles am I looking at? That will drive you to which equation to write. As always, if you had questions along the way, I hope you wrote those down, bring them in, and we will see you in class.